Hi there. So in this section, we're going to take a deeper dive into looking at quadratic functions and their equations themselves. What do they reveal about the parabola? And then after we've kind of got all the tools that we need in terms of these quadratic functions, we'll be able to put some applications to them because if you recall, in the last video I talked about, well, this minimum, a lot of this minimum down here would represent, okay, for example, it could represent a company that's trying to minimize their cost, or over here, a company that's trying to maximize their profit. Another example I could give you is, I know that you've seen this before in textbooks, where a person stands on top of a building and they throw an object up in the air, like for example, a ball. So they throw it up in the air, and this would be the trajectory. It reaches its maximum height, and then it comes back down and hits the ground. So we'll be looking at applications like that. So with that said, before we get to those applications, let's be sure that we can dissect our parabolas first, so once we get back there to those applications, we'll know exactly, oh, if we want to find a maximum revenue, oh, we're just talking about the vertex, okay, for example. All right, so I should say this, that quadratic equations are always represented in two forms. The first I have represented up here on the top is in standard form. So that's the y equals ax squared plus bx plus c. And there's also what's referred to as vertex form. So here on this page, we'll focus on vertex form, and on the next page, we'll focus on the standard form. Regardless, though, there are similarities between the two. By just looking at the equation, we would not have to do any work whatsoever in terms of determining whether the parabola opens up or opens down. And that has to do with your A value. So the A value you see here and the A value that you see down here in vertex form. If that A value is positive, your parabola opens upward. So here we're saying over here my A value is positive. If your A value is negative, then your parabola opens downward, like you see over here on the right. Okay, so hopefully that's very intuitive, that if it's positive, you open up. If it's negative, you open down. Also, from your equation, if it's in vertex form, you'll just be able to pluck the vertex. If it is in standard form, you'll have to do just a small amount of work, but you'll see that on the next page to find the vertex. But the vertex essentially is this lowest point down here, so that this particular vertex down here would be referred to as your minimum. Or it's the highest point that you reach, so this one up here would be a maximum vertex, okay? It's the lowest point or highest point on your graph. The axis of symmetry, once you have your vertex, the axis of symmetry falls right out. Essentially, the axis of symmetry is the vertical line that passes through the center of your graph, so it passes through the vertex and cuts your graph in half. Now, my graphs here are not perfect, but the idea would be that I could fold this one half of the graph over the other and it would be directly on top of itself, okay? But, of course, mine is not perfect here, but that's the idea, that you'd be able to fold it across this vertex and they would be just directly on top of one another, okay? Also, from your equation, you should be able to find x and y intercepts, and that's a throwback to previous topics that we've talked about. Remember, no brain dumping in Math 171. Anything that we talk about, you will continue to use throughout this course, and even more so, there'll be pieces that you'll use in trig, for those of you going on to take trig, and there will also be pieces for those of you, the majority of calculus is based out of pre-calculus here, okay? All right, so let's get started down here in a couple of examples looking at strictly just your vertex form. Vertex form is really nice because a lot of the pieces you can just pluck right out, okay, as I mentioned. The vertex form is y equals a parentheses x minus h squared plus k. H and k are just numbers, okay? The vertex is h comma k, so you can just, like I said, pluck the vertex from it. But notice how here this was minus h, and in the vertex form we have a positive h. So anytime you're plucking your vertex, it's always the opposite of h, and then you keep the sign of k. So if it's a positive k, it'll be a positive k. If this were minus k, I'd have a minus k here, okay? Like I mentioned a minute ago, the sign of A determines the direction that it opens. If it's positive, we're opening up. If it's negative, we're opening down. And then your axis of symmetry is always x equals h, and you'll notice here h is the x value of your vertex. Okay, so I'm just going to make that note for you. X equals h, and h is the x value of the vertex. Okay. All right, so we'll scoot on down then here to example 1. In example 1, we are clearly in vertex form. It wants us to find the vertex, the direction which it opens, the axis of symmetry, and then just do a rough sketch, okay? So vertex, we'll start there. Vertex would be opposite of H, so positive 2, then K. So your K here is a negative 4, so 2, negative 4. The direction that it opens, so I'm just going to put dir here for direction. Your A here is positive, so I'm just going to put here A equals positive. So we open up. There we go. Then we can spell better. There we go. Write better. All right, and then lastly, we want the axis of symmetry. I'm just going to abbreviate that as AOS. And axis of symmetry is x equals the x value of your vertex, x equals 2. All right, and then like I said, I'm just going to draw a rough sketch here. We'll focus on x and y intercepts in the as we move forward in the set of notes, but for right now, just a rough sketch. Plot your vertex. So we've got a vertex of positive 2, negative 4. So there's your positive 2, here's your negative 4. Put that vertex in. We know that it opens up, so it's going to look something like this. And I'll just go ahead and also draw in that axis of symmetry as well, because that is running straight down the middle here. Okay? And then that would be the line x equals 2. Okay, that blue line there. All right. I will let you do then example 2, because I think that's hopefully very straightforward. Remember, your vertex is the opposite of whatever's in parentheses, and then keep the sign of your K. Okay, so I encourage you to stop the video, try that one, check yourself by the solution key. I'm going to flip it on over, and let's focus a little bit more on standard form. The majority of quadratics are in the standard form. So with that said, then finding the vertex is a little bit more involved, but it's still very doable. It's a matter of doing a quick little equation here, negative b over 2a, and then after you find that negative b over 2a, you were just substituting. So this vertex is you find negative b over 2a, and then you plug negative b over 2a into your function to get the y value. So hopefully that makes sense. That's exactly what I was just saying here in the comments over here to the right. You'll hear me say, though, whenever I am doing my problems, instead of saying negative b over 2a, I'm going to say opposite b over 2a, so that it's ingrained to you that you're doing whatever your b value is, you're doing the opposite of it. So opposite b over 2a. Same thing as before, the sign on that a determines which way it opens. It's very intuitive. And the axis of symmetry is x equals the x value of the vertex, or you could think of it as x equals negative b over 2a, because right, the x value of the vertex is this negative b over 2a. All right, so let's look at example 3 here together. So we're finding the exact same things that we did on the previous page, and I'm just going to come underneath here and write our a, b, and c just so that we're clear on that. And if we want to find our vertex first, so to find our vertex, we need to first find our x value. So x equals opposite b over 2a. So if I do opposite b, since it's negative 8 already, then opposite b is going to be positive 8 over 2 times a, so 2 times 2. Clean up, 8 divided by 4. And then one last time, 8 divided by 4 would give me positive 2. So that tells me then, I'm just going to make myself a little note over here. My vertex, I have an x value of 2. Now to find the y value of my vertex, I go to my function, and everywhere I see an x, I plug in 2. So 2 squared minus 8 times 2 minus 1. So then that would be 2 times 2 squared, of course, will give you 4. Negative 8 times 2 will be minus 16 minus 1. Keep cleaning up, do your order of operations, 8 minus 16 minus 1. And then just go left to right here, put it in your calculator, whatever works for you, but you should arrive at negative 9. So I have a vertex at 2, negative 9. So I've got a vertex there at 2, negative 9. The direction of the opening, so we would say here that this opens, your A again is positive, so it opens up. And axis of symmetry, x equals x value of the vertex, so x equals 2. Remember, your x equals equations were always your vertical lines, okay? Then they want us to draw a rough sketch. So I've got the vertex here of positive 2, negative 9, so I'm just going to go here negative 3, negative 6, negative 9. I'm just going to count by 3s here. And this is 1, 2, so 2, negative 9. and I'm opening up, so it'll look something like this. It should be more rounded, but and anyway, that's our graph, and here's our vertex down here at the bottom. And would you say that vertex is a maximum point or a minimum point? Just sort of add that on there for you. Since it's down here, that lowest point, we refer to it as a minimum point, okay? And I'll pop in that axis of symmetry for you. Cut your graph right in half. Okay. All right. Well, I think maybe I should do one more. Maybe I'll do one more. If you feel like you've got it, then pause the video and you try the next two on your own. If not, maybe watch through another one with me, or try and get as far as you can, and then when you get stuck, come back to the video. Let's look here at example 4 then together. So here in example 4, again, I'm finding the same pieces. So to find my vertex, I'm in standard form. Here's your A, your B. You don't have a C value, so essentially that's like a plus 0 here, so C0. But your X value of that vertex, negative B over 2A. So opposite of your B, so this time B is positive 12, so negative 12 over 2 times negative 3. Negative 12 divided by negative 6, positive 2. To find the Y value of my vertex, I'll just come over here and identify my vertex. What we know so far, we know that it has an X value of positive 2. To find the Y value, negative 3. Everywhere I see an X, plug in 2. So 2 squared plus 12 times 2. Order of operations, got to square that 2's first. So negative 3 times 4. 12 times 2, of course, is 24. Negative 12 plus 24. And then that will give us a positive 12. Look at to now figure out which way it opens. It opens, A value is negative, so it opens down. And then we would need our axis of symmetry. Axis of symmetry, X equals X value of the vertex, X equals 2. So then if I do a rough sketch over here, I plot the point 2, 12. So here's 2, 2, 4, 6, 8, 10, 12. I'm just counting by 2s. 2, 4, 6, 8, 10, 12. Okay, and here's just 1, 2. 2, 12. That's my vertex. It opens down. So this time when I go to graph, I'm opening down. So it looks like this. That's not too bad. And then I want to, lastly, just put in that axis of symmetry. And again, the idea is that when you graph that axis of symmetry, it would cut your graph directly in half, and you could fold it over one another. It'd be a mirror reflection. Okay. All right. You definitely try example 5 on your own. I'm gonna flip it on over. Actually, was there another example down there? There wasn't. Okay. Sorry. I thought I'm looking at an old set of notes then. All right, so let's look at example 5 here. And truthfully, if you kind of look at this, if you look at everything that you see here, these are all things that we've talked about, okay? So you might want to take this quadratic function here and fill in as much as you can solo, and then come back to the video. But I'm going to work example 5 here from top to bottom with you, and then definitely you would do example 6 solo, okay? So this particular quadratic function is in standard form. So to find my vertex, it would be x equals opposite b, so negative 8 over 2a, so 2 times negative 1, right? Because remember, this is a, b, and c. Clean up, and I have negative 8 divided by negative 2, which will give me a positive 4. Now to find the y value of my vertex, I have the negative sitting out there. I'm replacing the x with 4 squared plus 8 times 4 minus 15. So then that would be negative 16 plus 32 minus 15. And then that will leave you at a positive 1 for your y value. So now we have a vertex. Let me see if I can. We have a vertex now. Our vertex is equal to 4, 1. I'm going to box that in. I'll try to put all my answers in red. Axis of symmetry, won't have to do any work. Axis of symmetry, remember, is the x value of your vertex. So x equals 4. Okay. Is your vertex a max or a min? That comes from thinking about, okay, well, does this parabola open up or open down? So since your a value there is negative, it opens down, and so since it, you just draw yourself a rough sketch. Well, if it opens down, then this point up here would have to be a maximum. So the vertex would be a maximum. Then it wants us to find the zeros. So in order to find the zeros, remember that's where you set your function equal to 0. So you have negative x squared plus 8x minus 15 equals 0. And you solve for x, just like we were doing in the previous section. I don't, whenever I factor, I never like to work with my leading term to be negative. So it is legal to go through and change all of your signs. So I'm going to do that. So x squared minus 8x positive 15. Then do my factoring. X and x, that's the only way to multiply to give you x squared. Most common way to multiply to give you 15. 3 times 5. With 5x and 3x, I can definitely get a negative 8 out of that. I'd have to make them both negative. And then if we set both of those equal to 0, hopefully you would see, okay, well, if I set that equal to 0, I'm going to get x equals positive 3. And if I set this one equal to 0, I'm going to get x equals positive 5. So I have zeros then at, my zeros then would be at 3 and 5. Now the next piece over says, well, what are your x-intercepts? Well, hopefully you recall from a previous lesson that x-intercepts and zeros essentially are referring to the same value. It's just how you report them. Zeros are just written as numbers, but x-intercepts are written as points. So I just need to take these two zeros here and write them as ordered pairs. So this would be the point 3, 0 and 5, 0. Those would be our two x-intercepts. Okay. To find your y-intercept, so hopefully you remember also from a previous lesson, when you're finding your y-intercept, you're plugging 0 in for x and you are solving for y. So I go to my function up here, and y equals, in place of that x, I'm plugging in 0 squared plus 8 times 0 minus 15. Well, the first two pieces are just going to go away, right? And so I'm going to be left with y equals negative 15. So the y value then of that intercept, the y-intercept then would be at negative 15. You can, hopefully even by now you might even be getting to where you say, oh, for my y-intercept, I'm just plugging zeros in for x. Those first two terms are going to go away. It's whatever the constant is sitting out here in the back, okay? So without showing the work. All right, so now in letter G, it wants me to draw a graph. So let me switch my color here on us. Drawing our graph, we'll plug in, we're going to graph everything that we have here. Okay, so we know that we have x-intercepts at positive 3 and positive 5. Get that smaller. 1, 2, 3, 4, 5. So here's 3 and 5. I've got x-intercepts there, 3 and 5. I've got a y-intercept at negative 15, so I'm going to have to count by 3. So negative 3, negative 6, negative 9, 12, 15. So here's my negative 15. And I had a vertex at 4, 1. So since I'm counting by 3's down there, I got to count by 3's here. So 4, 1 is going to be really small up there. And I got this y-intercept here. All right, so it's not the prettiest graph, but it looks like that. Should have scooted myself up a little bit further. And then I will go ahead and throw in that axis of symmetry right here, and this will be the line x equals 4. Okay, and that should hit everything. Now you'll notice the next three pieces are asking you for your increasing, decreasing intervals, domain, and range. So remember, for your increasing and decreasing intervals, if you put little arrows here on your graph, then if the arrows are pointing up, you're increasing. If you put little arrows here on the graph, if the arrows are pointing down, you're decreasing. So I am increasing then, and remember you're always reading your x-axis, from negative infinity to this x value of your vertex up here, so to 4. In just a second, it's froze on me. See if it'll come back. No. Okay. So it's increasing from negative infinity to positive 4. And then we would say that it is decreasing from positive 4 to infinity. Okay. your domain, since you go down and to the left forever, so you're going to the left forever, and you go down and to the right forever, you're going to left and right forever, domain, negative to positive infinity. And then your range here, remember reading from bottom to top, it comes in from, because remember this is the only time you read your y-axis, you're coming in from the bottom, so you're coming in from negative infinity, and then the highest y value you get is right here, and that y value is your vertex, and your vertex there is 4, 1, so it's coming in from negative infinity, and highest y value then is 1. And you can equal that 1, so the 1 gets a bracket, okay? Definitely encourage you to do example 6 on your own. And then I'm going to flip it on over and look at these applications here on the last page. So I think I'm going to work examples 7 and 8 with you. I'm going to work both of them, but by all means, if you feel good about it, then pause the video and try them on your own, okay? Here in example 7, it says the daily revenue achieved by selling X boxes of candy is figured to be R of X. So here's your revenue function. The daily cost of selling X boxes of candy is given here. So you've got your revenue function, you've got your cost function. Part A wants to know how many boxes of candy must this firm sell to maximize their revenue. So, what term have we talked about today that references that you are maximizing something? Hopefully you agree that that would be your vertex. And just sort of going ahead and letting you know like where we're headed. Anytime you see that word maximize or minimize, almost always you're referring to the vertex, okay? So here we are referring to, okay, we want the vertex of that revenue function. And so to find, I'm going to just write our revenue function here, that R of X is equal to, you notice how the revenue function is not in descending order? I'm going to rewrite it. So negative 0.04x squared plus 9.5x, okay, like so. So now to find how many boxes of candy, then that would maximize of the x value of the vertex, then I would have negative b, opposite b, so negative 9.5 over 2a, so 2 times negative 0.04. And then that would give you a negative 9.5 divided by negative 0.08. Divide there, and you get 118.75 boxes. And just so we're kind of all tracking in terms of, what would this graph look like? Here's your revenue function. We know it's a parabola. I'm just going to do a rough sketch here. We know it's a parabola, right? Because it got an x squared term here. So, and your leading coefficient here is negative. So it's a parabola that's opening downward, like so. And what else did I want to say there? Oh, and what's being measured on the x and y axis? X-axis, the x-axis is the x value here, and they've told us that x stands for the number of boxes of candy. So this would be the boxes of candy here. And the y-axis would be whatever, R is, and we know, well, R is the revenue, okay? And so what we're saying then here, this point right here represents, okay, well, if this is 118.75, when they sell 118.75 boxes of candy, they get a maximum revenue. So now to figure out what that maximum revenue is, it's kind of like here up here at the vertex. We know what the x value is. Let's find out what the y value is, just like we were just doing, okay? So to find the y value, we go to my revenue function. And everywhere we see an x, we plug in the 118.75. So that will look like this. Negative point, let me actually come down here. Okay, I'm gonna bring it down here just because I was gonna run out of room. Negative 0.04 times the 118.75 squared plus 9.5 times the 118.75. Just go to your calculator, plug that all in at one time, and you should get $564.06. I can't remember now if there are more decimals out there, but because you're finding revenue, revenue is money, so let's just do like we normally would do in terms of dollars and cents. So the maximum amount of boxes they need to sell is 118.75. Their maximum revenue is 564.06. So this is max revenue. Max revenue. And so then it tells me over here, okay, well, this is 564.06. Okay. Part B says profit is given by this equation, that P of X is equal to revenue minus cost. They want us to find the profit function. So they want us then that, okay, well, P of X would equal my revenue function. So let me put in my revenue function, negative 0.04x squared plus 9.5x. I'm just going to put that in parentheses, minus my cost function. And the cost function they gave us up here, which was 1.25x plus 250. All right, so now just start cleaning up. So I have negative 0.04x squared plus 9.5x. This is a negative 1 here that needs to be distributed. So minus 1.25x minus 250. Final answer will be to combine like terms, which would be these x terms here in the center. So our final profit function then will be negative 0.04x squared plus 8.25x minus 250. Final answer. Okay. Now as we head down to part C, it wants to know how many boxes of candy must the firm sell to maximize their profit. So again, you see that word, okay, I want to maximize my profit. That means I've got to go back to that equation that we just calculated, and I want to find the vertex of that equation. So my vertex of that equation, x equals, make that smaller, opposite b, so negative 8.25 over 2a, 2 times your negative 0.04. So that's negative 8.25 divided by a negative 0.08. Divide there, and that should land you at 103.125. So 103, a little over 103 boxes will give them maximum profit. You know, and by the way, for this function, kind of the same deal. Along the y-axis, you're measuring profit. Along the x-axis, you're still measuring the boxes of candy. Your a value is negative, so you're still opening downward. It's just that this time, okay, my profit's up here, maximum, and that represents now an x value of a little over 103 boxes of candy. Now to figure out the max profit, you go to your profit function. Everywhere you see an x, you plug in that 103.125. So you have negative 0.04 times the 103.125 squared plus 8.25 times the 103.125 minus 250. Put all of that in the calculator, and again, it's money, so round to dollars and cents. So the max profit they would be reaching is $175.39. So this is those two pieces there. This is the maximum number of boxes, and then this is your max profit. Okay? All right, let's close up shop here together with example 8. Looking here at example 8, it says the height of a ball is thrown directly upward from a point 200 feet above the ground with an initial velocity of 40 feet per second. I kind of like to always, I was doing these pictures before for you in the last piece. I like to do those again here, just to kind of give you a visual kind of what's happening. That we know that we've got a ball that's being thrown from a height of 200 feet. So here's your 200 feet is being thrown upward, and then at some point that ball has got to come back down. So that's kind of the idea of what's happening here in this particular problem. You know what? I just noticed that this is mislabeled here. This is not ACD. This would be ABC. Sorry about that. Okay. Then they give us, the initial velocity, but they go ahead and tell us, okay, here's your height function, negative 16t squared plus 40t plus 200. Notice how that 200 is sitting out there at the end, and notice where that 200 is. That would essentially be, that's your y-intercept, right? Because if you plug 0 in for both of those t's, I've got y left in at 200, okay? Just to sort of help you in terms of, where all of these pieces, how they tie in together. T represents the amount of time elapsed since the ball was thrown. T is time in seconds here, and H is height in feet. So this would be on the y-axis, we're measuring height in feet. And along the x-axis, we are measuring time in seconds. Okay? Part A says determine the height of the ball after 3 seconds. So they've given us our function. They just essentially want us to find h of 3. Everywhere we see an x or t here, we're going to plug in 3. So you have 3 squared plus 40 times 3 plus 200. Multiply and add, and you should land at 176 feet. So that equals 176 feet. All right, so we'll say here that this is, we'll say, well, I'll wait. Part B wants to know, when did the ball hit the ground? So when the ball hits the ground, that's when your height, here's the ball hitting the ground. At that point, what does your height equal? If you agree, my height would equal 0. So when the ball hits the ground, your height equals 0. So I would have negative 16t squared plus 40t plus 200 equals 0. I am going to, all three of these terms all have an 8 in common. I'm going to factor out, and actually I'm going to go ahead and factor out a negative 8, so I don't have to worry with so much of this. So I have negative 8 parentheses, oops, I already had my parentheses there, didn't I? Negative 8, and then I would have, what's that, 2t squared, let's see, minus 5t minus 25 equals 0. Now let's factor. Only way to multiply to give you 2t squared, 2t times t. And then most common way to multiply to give you 25 would be 5 times 5. Outside's giving me 10, right? Inside's giving me 5. I want a negative 5, so I would need to make the 10 negative. This is where I'm getting the 10, so put the minus in front of that. Here's my plus. Set both of these pieces now equal to 0. So if we set the first one, 2t plus 5 equal to 0, you're going to subtract your 5. 2t equals negative 5, divide by 2. You can get t equals negative 5 halves. Remember, t represents time. So a time of negative 5 halves seconds is, or negative 2.5 seconds does not make sense. So we will X that one out. Come over here to the t minus 5 though and set that equal to 0. We just add 5 to both sides. And so t equals 5. So at this point right here represents 5 seconds. So at 5 seconds, that ball has hit the ground. And then lastly, in part C here, when does the ball reach its maximum height? So they're asking me for the time. All right, so when does it reach its maximum height? They want the x value of the vertex, and then they want what is the maximum height. They want the y value of the vertex. So we're just finding our vertex here. We are in standard form, so our vertex is opposite b. So opposite b, negative 40 over 2a, 2 times negative 16. So I end up with negative 40 divided by negative 32. Do that division, and we should land at 1.25 seconds. So at 1.25 seconds, so my picture's a little off here. Right? Yeah, my picture's a little off. Well, yeah, my picture's a little off because it should have gone, I guess, up. It was had a more of a velocity to it, but nevertheless, we're saying, okay, well, that's my 1.25 seconds the way I've drawn it. Here's what 1.25. At 1.25 seconds, it reaches its maximum height. What is the maximum height? So we find h now of 1.25. So I have negative 16 times 1.25 squared plus 40 times 1.25 plus 200. Plug all of that in the calculator, and you should land at 225 feet. And so we're saying, okay, well, this is 225 feet up there, right here. That's my 225. And then if you think about it, like if that's 225 feet there, and we found originally that in 3 seconds it was 176, so like 176 would be here. It's a, I mean, like I said, my picture's a little off, maybe like a way off, but nevertheless, you don't know it when you're first drawing a rough sketch, and that's what I did here. Okay. All right. Well, let me know if you need anything, and thanks a lot. Bye.